Welcome to doassignment-ca. Here's the problem. A freight train travels at a velocity v equals 60 times the quantity 1 minus e to the negative t in feet per second, where t is the elapsed time in seconds. Determine the distance traveled in 3 seconds and the acceleration at that time. Now, let us work through the solution step by step. We are given the velocity as a function of time, v equals 60 times the quantity 1 minus e to the negative t. We need to find the total distance traveled over the first 3 seconds and the acceleration at exactly 3 seconds. Distance is the integral of velocity over time. Because the velocity is always non-negative for t greater than or equal to 0, we simply integrate v from 0 to 3 seconds. We split the integral into 2 parts. The first part integrates 1 with respect to t, giving t evaluated from 0 to 3, which equals 3. The second part integrates e to the negative t, giving negative e to the negative t. Substituting the limits and simplifying, we get 180 minus 60 times the quantity 1 minus e to the negative 3. Substituting e to the negative 3, which is approximately 0.04979, we compute 60 times 0.95021, which is about 57.01. Subtracting from 180 gives us approximately 123.0 feet of distance traveled in 3 seconds. Acceleration is the derivative of velocity with respect to time. Differentiating 60 times the quantity 1 minus e to the negative t, the derivative of 1 is 0, and the derivative of negative e to the negative t is positive e to the negative t. So the acceleration equals 60 e to the negative t feet per second squared. Plugging t equals 3 into the acceleration function gives 60 times e to the negative 3, which is 60 times 0.04979, approximately equal to 2.99 feet per second squared. To summarize, the distance traveled in 3 seconds is approximately 123 feet, and the acceleration at 3 seconds is approximately 2.99 feet per second squared. As a quick check, at time 0, the velocity is 0, confirming the train starts from rest, and as time grows large, the velocity approaches 60 feet per second, while the acceleration approaches 0, both of which make physical sense. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.